Today we're continuing our discussion of arrays by focusing on some of the features of arrays. In part one of the discussion of arrays, you learned about the fundamentals, and so now we're going to be talking about how they can be deployed in functions, how you can use a partially filled array, because you remember one of the big limitations is that we have to declare the size of the array at compile time, and sometimes we don't know until runtime how big our array should be. So partially filled arrays will be the answer to that question. And then sometimes our data is multidimensional. Actually, a photo is a good example of that. It really is a two-dimensional diagram. So it has rows and columns of pixels. So actually, you would probably want to represent a photo as a two-dimensional array of data. So we'll talk about that as the last topic today. So we're going to talk about, or start by talking about, using arrays and functions. And there's two ways to use arrays in functions. First, you may just want to pass individual elements of an array. So in this piece of code, what I am wanting to calculate is the maximum of two of my temperature elements, the ones that are in index location 3 and the one in index location 5. Now remember, these are actually the fourth and sixth elements in my data set because the indexing begins at 0. So in this case, I'm just passing their values to my max function, and because my array is an int, it's passing two int values. Therefore, my arguments match the types of my parameters because temperatures of 3 and temperatures of 5 are both ints. So I can pass individual elements to an array. I also can pass the entire array as a function parameter. And I do it by simply passing the name of the array. Now, usually, I also need to pass the size of the array because the function would be pretty inflexible if it could only deal with arrays of a certain size. So normally, when you pass an array, you actually pass two arguments. One is the name of the array, and the second argument is the size of that array. And array parameters behave like call by reference parameters. So if you change an array parameter, it actually changes the original array that was passed in as an argument. So again, array arguments behave like call by reference parameters. Unfortunately, this is an inconsistency in C++, although array parameters are passed by reference, you don't declare them by reference. So here's an array parameter, and as you can see, it is not declared by reference, but nonetheless, C does pass it by reference. You can't stop that from happening. You also see that we don't declare the size of the array. This enables us to have maximum flexibility. If I was an array dealing with a photo, it would be very inflexible to say only have an array that could deal with a 1 megapixel photo. You want it to be able to deal with photos of different sizes. So we don't declare the size of the array. That's why we also pass the size of an array as a separate parameter so that our function is able to know how big the array is. So here's an example where we want to have a function read scores into our array. So we basically want our function to initialize the array. Now notice I'm using my good practice of declaring the size of array as a const and using the size variable, to declare the size of my scores. And then I call fill scores and pass it the scores array and size, and then fill scores is a void array. I don't need it to return anything, but I do need it to modify the array. So I declare my counting variable n, have n count its way through the array, And for each element in the array, we prompt the user for a score, and then we read that score into the array. And then finally we return. Now many of you are going to be tempted to say, oh, I know what the size of score is. It's size, so I don't really need to have size right here. I can just say for n equals 0, n less than uppercase size. This is a horrible habit to get into. As I said, it makes your array or function completely inflexible. It means it can only now fill arrays of size 10. But maybe you have multiple places in your code where you want to call fill scores and you're passing in arrays of different sizes. So please, please do not hard code your array sizes into a function, but instead pass them as parameters. Now, I said that arrays were passed by reference. What if I absolutely want to tell the compiler under no circumstances should the array be changed in the function? How can I do that? In effect, how can I change it to call by value? You can do so by prepending the keyword const before your parameter declaration. And when you do that, it says even though it's passing it by reference, I don't want to allow any modifications to this array. And so that's just a way of enforcing for all time that if someone tries to do it, the compiler will generate an error message. It's a promise to the compiler we will not modify the contents of this array in this function. So here's a couple arrays don'ts. First of all, we can't return an array using a return statement. That's just a restriction of C++. There's no reason why, I guess fundamental reason why it couldn't happen. The developers of C++ decided they weren't going to allow it. So you could, in your function, declare a local variable called weights, but it would be illegal to actually return weights to the calling function. So don't return an array from a function. The second thing, we already talked about it, don't try to modify an array parameter you declared as const. If you really need to modify it, get rid of the const declaration. Okay, so let's now just write a definition of a function called SumArray, and it's going to receive two parameters, an array of ints and an int that contains the number of elements of the array, and we want to return the sum of the elements. So actually I've set up CodeLight for this little exercise. So I want to write the definition of a function named SumArray, and it receives two parameters, an integer array, so I'll just call that, say, num. Remember, you don't declare the size of the array. And then I'm passing a second parameter, which is an int that contains the number of elements. So I'll call that size. And it returns the sum of the elements of the array as an int. So that's returning an int. And we want to sum the elements, so I need a counter variable, and I'm going to use my friend the for loop to count my way through the array. I'll count up to size, and for each element in it, I'm going to be summing it up. So set sum to equal to num and whatever location we're currently at in num. I need to add another variable up here called sum and initialize it to 0. And when I'm done, I can simply return sum. So that's my function for summing the elements in an array. And finally, notice since I never modified the elements of num, up here I could actually declare it to be a const parameter. So moving on, let's say we're going to talk about partially filled arrays. So oftentimes the size of our data is unknown. We don't know how big the photo is. We don't know how many temperature observations we have. Yet C++ forces us to declare the size of the array when we compile it. So to handle this situation, what we can do is just declare a very large size array and then use only part of it. And normally we will make the array bigger than what we think could possibly be the largest size of the data. And now if we do pass the array to a function call, we won't pass the size of the array because that's irrelevant. We'll simply pass the number of elements currently residing in the array. So for example, we might have an array declared to be of size 100, but if there's only 50 elements occupying the array, then we would pass either 49 or actually, in this case, I would say pass 50 as the argument to the function, because that's the number of elements that are actually in the array. Okay, so here's an example of using just the occupied part of an array instead of an entire array. So I am reading a set of scores. Maybe it's the golfers who participated in a tournament, but I don't know in advance how many scores I have. So it's going to change with every time I run the tournament. So I'm going to declare, I don't think I'll ever have more than 10,000 golfers in my tournament. So I declare a constant max size to be 10,000. I declare my score array to be 10,000. And then I will assume that I can ask the tournament organizer at runtime, how many scores are you recording? They will input that many scores. Now when I call fill score, remember you saw it just a few moments ago, but now I pass in num scores, which is the number of scores I'm recording. So now size is not the size of the array, but the number of scores I'm recording. And I simply run my loop again, but now when I prompt, it's the same loop you saw earlier in this lecture for filling up the score array, but now I'm only partially filling the array. So this is another good example of why you should not be hard coding the size of the array. In this case, the size of the array was irrelevant. What was relevant was the number of elements I was reading into the array. We'll finish off today with a discussion of multidimensional arrays. As I already talked about, there's a lot of situations where a one-dimensional array is inadequate, and I've got a number of examples here. Maybe I've divided a plot of land into a grid, and I want to record the number of distinct plants in each grid. I had a friend who was getting their master's in plant science, and that's something that they did for part of their research. Okay, well, the grid is presumably going to have some rows and columns, so it's really two-dimensional, not one-dimensional. What if I want to represent airline fares between cities? Okay, there again, it's kind of a two-dimensional table that you're probably used to looking at. Like the rows might be the from cities and the columns might be the to cities. Maybe I want to represent the temperatures by year, month, and day. This is actually a three-dimensional array because one dimension is the year, one dimension is the month, and one dimension is the day. Okay, and finally I might want to represent the coefficients for a system of equations. I might have, say, 3x plus 4y minus 5z equals 0, and 2x minus 5y plus 10z equals 20. And I want to represent these coefficients. I probably want to have a two-dimensional array where the rows might be the number of equations, and the columns would correspond to the coefficients of x, y, z, and the value over here. So a lot of examples where a one-dimensional array is not a suitable representation for my data. Now you can always squash a multi-dimensional data into a one-dimensional array, but it's not the easiest way to manage it. So C++ supports multi-dimensional arrays. In this course, you're primarily going to deal with two-dimensional arrays. So here we have airfares, very simple one. We have a 2x3 array. And the best way to think of a two-dimensional array, in my opinion, is as a table. So the first dimension is the number of rows, and the second dimension is the number of columns. So you could kind of think in general of a two-dimensional array as a table, with the first dimension being the rows and the second dimension being the columns. So here I'm kind of thinking of it as there's two cities, City 0 and City 1, and we can go to destination cities 0, 1, and 2. So to go from City 0 to City 1 is $230. And as you can see, the number of entries is equal to the number of rows times the number of columns. Now, if we pass a two-dimensional array to a function, we change the convention for declaring the dimensions. As before, the first dimension is undeclared. The number of rows is undeclared, but we do have to declare the number of columns. And it's a technical reason. I'm not going to get into it, but you should just memorize the fact that in a two-dimensional array, the first dimension is undeclared in a parameter, but the second, or columns, is declared. And then again, just like with one-dimensional arrays, we pass the number of rows as a second parameter. And then we may want to have multi-dimensional arrays. So here's my example of I want it to have temperatures and over a number of years, months, and days. So this is one where I'm collecting 10 years of data. That's the first dimension. And then each year has 12 months, so I'm organizing the data by months. And then I have each month has 31, well, up to 31 days. Notice the last dimension may be only partially filled because some months have only 30 days. February has only 28 days. So not all of the array entries may actually be full. Also notice I could squash this down. I know there's 365 days in most years, or in a leap year 366, but it's probably easier, or maybe for whatever reason I want to organize the data by months, so I really would like to have a three-dimensional table. So in general, a multi-dimensional array is simply a list of however many dimensions you need enclosed in brackets, separate brackets for each dimension. And again, the indexing starts at 0 for each dimension and goes up to the maximum size minus 1. So there's 10 years, so the maximum index for the years is 9. There's 12 months, so the maximum index for months is 11. And there's 31 days maximum for each month, so the maximum index for days is 30. And just like two-dimensional parameters, if you pass a multi-dimensional array as a parameter, the first dimension, which you can still think of as the number of rows, is undeclared or undefined, but the remaining dimensions must have fixed size. Again, it's a technical reason. It has to do with implementation. Certainly makes our functions a lot less flexible. It's just the way it is. In C++, you have the most flexibility with your one-dimensional arrays. And again, here we would pass in the number of years as our extra parameter. And then here's a sample function call. Again, it doesn't matter how many dimensions it has. When you actually call the function, you always just give the name of the function or of the array. So here was the actual array declaration in the calling function. So we're going to end with a demo using two-dimensional arrays, and we're going to be printing out the average temperature for each month. So we have January, February, March, April, May. We want to calculate the average temperature for each month, and we're just going to assume that each month has 30 days. I know some have 28, some have 30, some have 31. For convenience, we'll assume each month has 30 days. So we want to write a code fragment that declares this array and then computes the average temperature for each month and prints its average. So we'll start, and being good about it, we'll declare some integer constants. So months is 12 and days is 30. And now we'll declare our array. We'll assume it stores integers. And we'll use months as the row and days as the column. Now to make some room, I'm going to get rid of the top part here, and I'm going to calculate the average for each month. So for that, I'm going to need two counting variables. I'm going to need an outer and inner loop. So the outer loop is going to be iterating through the months. And notice I'm not hard coding 12, but instead I am using the constant for it. So I want to get the average for each month. Well, each month has 30 days of data, so I need to iterate then through the days in that month and add them to my sum. So months is the same, days will be varying. And when I'm done, I will print it out, and I'll assume that I want that as a double, so I'll need to use a static cast and cast my sum variable to a double and divide that by the number of days. Again, don't hard code number of days. We might later want to change it, say to 31. And now I can terminate my outer loop as well because I've calculated the average temperature. And again, I just need to emphasize, don't hard code the size of your arrays into your programs. Instead, use constants so that they're easy to modify. Okay, so we'll finish up with converting our code fragment to a function. We'll assume that we want this function to compute the average for each month, but instead of printing out the average, we want it to store the result into a second one-dimensional array that keeps track of the monthly averages. And we want this array of monthly averages returned from our function. Now you'll remember we can't return an array from a function. So the only way we're going to be able to, quote, return an array is to pass it in as a argument to our function. So we'll actually declare our function to be a void, compute average, and we pass in temps. And the first dimension's undeclared. The second one we have to declare, it's days. We'll pass in the number of months. And we'll pass in our second result array. We'll call it average temp. Okay, so one-dimensional array, and we don't declare its dimensions. We don't need a separate parameter for its size because we assume it's also num months. And let me just make this smaller so it fits on one line. And now I can take my code from the previous slide and we're just going to modify it. Okay, and we'll make sure that we terminate that. So we just need to now do everything like we did before. Instead of now in our cout, we're no longer printing. Instead, we're assigning to average temp. and we're assigning to whichever month we're currently computing the average for. So this statement will assign the average for that month to the appropriate entry in average temperature. And that's it. That's the only real modification we need to make to our code. Actually, that's not true. Notice here we have to change months to num months because that's being passed in as a parameter. It is okay to hard code days because we had to hard code it up here in our function declaration. So that concludes our discussion of arrays, and we'll be moving on to talk about vectors in our next lecture.